Hello dear students, welcome to Pen and Paper Chemistry on YouTube. The heading that we are covering today is variation of conductance G, conductivity kappa, molar conductivity lambda m with dilution of solution, or what is called as decrease in concentration of the solution. And what do we mean by this sign? Yes, that you have to get a pen and paper ready so that you can take down the notes for future reference and for reference when you are offline. So pause the video, get a pen and paper, and let's start with the heading. Now while discussing this heading, I will assume that you already have a knowledge about kappa and lambda m. What are the formula for it and what do these terms mean? To explain the two, I have taken a case where we have a class where there are 6 students in the class and these are spread in the entire space that is provided to them. Now what do we do next? We double the volume of the class, we double the size of the class, and at the same time we have added 2 new students to the class. Definitely the students will spread themselves around. Now when they spread themselves around, the number of students who are present in the same space or similar space that was being provided to them earlier has now, if you notice, reduced. If there were 6 students in a given space over here, there are only 3 students left in the new room. But the number of students overall in the room has actually increased, and that explains the whole concept or variation of conductivity and molar conductivity. Conductivity is dependent upon the number of particles which are present in a unit volume of the solution. So here there are 6 particles in the unit volume, whereas here there are only 3 particles present in the unit volume. So on dilution, kappa, conductivity will decrease or increase? Very correct, it will decrease because the number of particles which are present in a given volume of the solution has actually gone down. What about molar conductivity? Here you have to understand that molar conductivity is due to the number of ions in the given volume of the solution, in the entire volume of the solution. So when in the first case we had only 6 students in the class, in the new case, although the class size has got doubled, there are 8 students in the class or 10 students in the class, right? So the decrease in the number of students per unit volume is actually compensated by the volume of the entire class. So what we find over here is that the molar conductivity actually increases in contrast to kappa, which decreases. See from the formula as well, molar conductivity is kappa divided by molarity. Molarity is number of moles divided by volume, right? Now kappa is decreasing, yes, but if you notice, volume is increasing many-fold. So the decrease in kappa is, or conductivity, is compensated by the increase in the volume of the solution, right? So how do we explain this? I have got a small chart for you which explains this entire thing in a bird's eye view. We've got variation of conductivity, conductance, molar conductivity of a solution upon dilution or decrease in concentration. So I've tabulated conductance, conductivity, molar conductivity, increases, decreases, increases. A reason for variation is also listed. So conductivity, it is due to the number of ions present per unit volume of the solution. Because that is decreasing, the conductivity of the solution also decreases. On the other hand, molar conductivity is dependent upon conductivity as well as molarity or volume of the solution. So, the decrease in conductivity is compensated by the increase in the volume of the solution, which explains the increase. But to what extent does this increase show in strong and weak electrolytes is what we are going to study as a separate heading in the next video. Please go ahead. You may also add points so that it is easier for you to recall and your notes are complete for offline reference. Happy studying to all of you. See you in the next video.